Friends, my name is Girish Rodkar, and in this session we are going to learn about vapor compression cycle. Now, vapor compression cycle is used in almost all refrigeration systems like refrigerators and your freezers, chillers, and even in ACs. This system is used. Friends, let us understand how this system functions. Let us understand how it works. To understand its working, let us take some petrol on palm. When petrol is taken on palm, you will realize that petrol absorbs the heat from your palm, and then it gets converted to vapor form. Now this heat which is being absorbed from your palm is called latent heat. Remember friends, when the latent heat is absorbed by the petrol gets converted from liquid form to vapor. And you should also know that the pressure and the temperature in this process of the petrol, it remains same. So whenever latent heat is absorbed, the pressure and the temperature of the fluid do not change. Similarly, now if you want to bring that petrol which is in the vapor form back to the liquid form, the heat will have to be rejected. See, in the earlier process, when you had kept it on your palm, it had absorbed the heat and it had got converted from the liquid form to the vapor form. Now, if you want to convert it back from the vapor to the liquid form, the petrol which is in the vapor form will have to reject its latent heat. And when it does that, it will get converted from the vapor back to the liquid. In this process also, the pressure and the temperature of the petrol will not change, but its state, which will change from the vapor form to liquid. So friends, these two processes you have to remember. One is the process of a latent heat absorption, wherein the state changes from liquid to vapor, and another is the process of latent heat rejection, wherein the state of the petrol changes from vapor to liquid. Now let me tell you, the process of latent heat absorption takes place in a device called evaporator, and the process of heat rejection takes place in the device called condenser. So condenser and evaporator. So now we will start with the actual sketch, and I'll show you how the refrigerator system functions. Hello friends, in this session I am going to teach you how a vapor compression cycle works. Now let me tell you, basically the vapor compression cycle is used in equipments like a refrigerator, then air conditioner, freezer, water coolers, etc. Now the system consists of a compressor, then condenser, then receiver, expansion device, and evaporator. This is called evaporator. Now the compressor and all other equipments, they carry a fluid called refrigerant. So refrigerant flows within the system. Now let me start from this point. Here is the refrigerant, and this refrigerant has low pressure, low temperature, low pressure and low temperature it is, and it is in the vapor form. Now the compressor sucks the refrigerant, and while exiting it, it increases its pressure and temperature. So here you can have high pressure and high temperature refrigerant again in the vapor form. The same refrigerant then goes to the condenser. Now condenser is nothing but a type of tube which is sometimes also provided with fins. Now as soon as the refrigerant passes through the condenser, it loses its latent heat. Now you should remember that the refrigerant has reached to such a state that it starts rejecting its latent heat. Latent heat is being rejected. Now friends, you should know, when the refrigerant loses its latent heat, its pressure does not change, nor does it temperature. So pressure and temperature, they do not change when it loses its latent heat. Now here at this point you can have the liquid refrigerant. Remember, when the refrigerant loses its latent heat, it gets converted to liquid form. So liquid refrigerant at high pressure and high temperature goes to the receiver. Now receiver is a type of, this is the receiver. It is a type of receiving equipment which stores the excess refrigerant and sends out the desired refrigerant to the expansion device. Here also you can expect high pressure and high temperature refrigerant in liquid form. Now once this is done, the same refrigerant goes to the expansion device. Now expansion devices are of various kinds, which we will be learning later. Now the speciality of expansion device is that it expands the refrigerant and the refrigerant suddenly loses its pressure. So low pressure, and when the pressure is lowered, the temperature also is lowered, but the refrigerant remains in the liquid form. Now the refrigerant from here, it has reached to such a state that it will start losing its latent heat. So here it will lose the latent heat. I committed mistake. It will not lose, but it will absorb. It has reached to such a state that it will absorb the latent heat. Latent heat is lost in the condenser, and in the evaporator it absorbs. Now when the latent heat is absorbed from the surrounding, the temperature of the surrounding will go down because the heat is being absorbed. And as such, while leaving the refrigerant from the evaporator, it will have low pressure. See, pressure is constant and temperature is also constant. So whatever pressure you have here, it is less whatever temperature you have here, it is less. The same temperature will prevail at the exit. The temperature will be less, pressure will be less, but the state will change from liquid to vapor. That is the principle. So you had started from the refrigerant which was having low pressure and low temperature and in the vapor form, and you have finished at the same state, the state being the same, low pressure, low temperature and low vapor. Friends, let me tell you once again, the condenser, it rejects the latent heat. So if you hold your palm near the condenser, you will feel hot, and the evaporator absorbs the latent heat from the surrounding. So whatever food stuff or whatever you keep near the evaporator, the heat will be absorbed from that and the things will get cooled. So this is how a vapor compression cycle works in general. See, in this video I have not explained to you whether the refrigerant is in the superheated form or saturated form. I have simply explained to you how it functions without considering the refrigerant in its detailed form.